Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from economic load dispatch. Here in this video lecture, we will cover a topic revision of a cost curve and incremental cost curve of a thermal unit. Now before that, we will see some important terms. Now the first term associated with this is nothing but input output curve of a unit. Input output curve of unit. So I'll draw this first and then we will discuss what is the meaning of input output curve. So I'll draw it here. As we know, curve is nothing but what? There are two axes. So this will be x axis, this will be y axis. On x axis, we are going to take output power in megawatt. On y axis, we are going to take here BTU per hour. BTU is a British terminal unit. So we can say this will be your fuel input. Or in other words, we can write it as it is kilocalorie per hour, okay, into 10 raised to plus 6. So what is the nature of this curve? So I'll draw it like this. So this is the nature of a curve. I'll draw this curve by a solid line and the remaining curve will be by a dotted line. Now what is this? This will be your PG minimum, or I can say that this will be your minimum megawatt. Then this will be your PG maximum. So this is nothing but your maximum megawatt. So what you observe here, for an economic load dispatch problem, it is necessary to know the input curves or input output curve of all the units to be committed. Here it establishes a relationship between whatever will be the energy input to the turbine and energy output from the electrical generator. Now the input to the turbine, which is to be shown on the y-axis, this is the input to the turbine. It may be either in terms of heat energy requirement, which is generally measured in BTU per hour, or we can say it is kilocalorie per hour, or in terms of total cost of a fuel per hour, that is it will be in rupees per hour also. Now the output is normally a net. This will be the output. Output is normally what? It is a net power or net electrical power which is to be coming from a steam unit. It might be in a kilowatt or it might be in a megawatt. Now in practice, if you see, the curve may be very smooth, and from a practical data, such an idealized curve may be interpolated. Now, if you see what is the nature of this curve, the nature of this curve is a non-linear curve. Here you have seen that there are two limits. First one is the PG minimum, second one is the PG maximum. So why there are two limits here in the graph, in between whatever solid line here we have drawn, or what is the meaning of this representation? Now, for any generator, it has to be operated at a certain minimum generation. Otherwise, there is no point to start a generation. Let's have a look for this. Suppose PG is the power generated by generator 1. So I'll write it as a generator 1. So there has to be certain limit. It will be what? It will be some kind of PG minimum and it will be some kind of PG maximum. I'll give you a very simple example. Suppose if I have a two-wheeler, then for that two-wheeler, there is a minimum speed and maximum speed. Minimum speed is 0, maximum speed it might be locked up to 100 or 120 km per hour. So same way, this generator have two limits. Minimum generation has to be there, maximum generation has to be there. Below that, below your minimum generation, it is not possible, it's of no use to keep it on that particular generator. And above this maximum generation, that generator is not capable of producing higher amount of a power. Now, PG maximum is the maximum limit on the power to be generated. Now, these whatever these minimum and the maximum generation will be there, these limits depends upon steam cycle which is to be used, the thermal characteristic of the material and operating temperature. So, this will be a PG minimum, this will be of a PG maximum. Now here, if a cost for kilocalorie which is shown in the input output characteristic curve, it can be converted into fuel cost curve also. So please remember, what is this input output curve of a unit? It is the curve which is drawn in between output power megawatt and whatever will be a fuel input to the turbine. It will be in BTU per hour or kilocalorie per hour. So what information it gives you? This information gives you whatever will be input which is given, how much amount of a power will be generated. And these are the two limits, PG minimum and PG maximum. So again, for understanding these two limits, let me tell you again one example. We know that water boils at 100 degrees Celsius. Means what? At 100 degrees Celsius, it will be converted into steam. But it is not like that. The process always starts at 100 degrees Celsius. No. It might be start from somewhat 70 degree or 75 degree, 80 degree like that. So therefore, here, if I want to convert that water directly into the steam, what will be the temperature required? It should be up to 100 degrees Celsius. Below which, yes, it starts, but definitely it will not reach to what? 100% steam generation. So this is what is we can say, it is a minimum requirement for converting that water into a steam, that is 100 degrees Celsius. So there has to be some minimum generation from the generator, and there has to be some maximum limit above which it is not possible to generate some kind of energy with the help of that generator. Now the second point is nothing but a cost curve. What I am going to explain now is cost curve. Now what I will do, how this cost curve has been drawn. Again the diagram has been same for the cost curve, just the axes are different. Here on a y-axis there will be rupees per hour. The diagram is like this, it is same only. This will be dotted line, again this will be a dotted line. These are the solid lines here. So this will be your PG minimum, it is same in megawatt, and this will be your PG maximum, again it will be same in a megawatt, and this is your output power which is always in megawatt. So how we are getting this cost curve? With the help of input output curve. In order to convert this input output curve into cost curve, what we have to do? We have to, whatever fuel input, now if you see this fuel input per hour is multiplied by cost of a fuel, by cost of fuel. What is the cost of a fuel here? You can take it as rupees per million kilocalorie. So what I will do, please see it carefully. Here we have written kilocalorie per hour into 10 raised to 6. So what I will do, I will write it here, kilocalorie per hour into 10 raised to 6. And what I am going to do, I am going to multiply it with what? This cost of a fuel, which will be what? Rupees per million kilocalorie. So if you see what will happen, this kilocalorie 10 raised to 6 million kilocalorie will cancel, and we will get it as rupees per hour, which will be on a y-axis. Please remember, when we are talking about a British terminal unit, then 1 BTU will be equal to 1055.058 joules. So this is the unit of BTU into a joules. So this is the second topic, which is called as cost curve. Now the third point related to this is nothing but a heat rate curve. Let me tell you what is the meaning of heat rate curve. So first I will draw a diagram for a heat rate curve. So again, if you see, there will be output power in megawatt. Here there will be input, that is a heat rate. We can say input heat rate, it will be in BTU per kWh. And whatever relation we will get here, it is like this. The curve is like this. So what is a heat rate curve? I can say simply, what is the meaning of this? How much energy is expended? How much energy is expended in order to obtain a unit of useful work. A unit of useful work. Okay. So how we can define the heat rate? The heat rate is the ratio of fuel input in BTU per hour to the corresponding output in kW. So I will write it here, heat rate curve. I write it as heat rate curve. It is the ratio of fuel input. Whatever will be a fuel input given. Now the unit for this is what? It is BTU per hour. Whatever will be fuel input divided by corresponding output, whatever output power which is produced. Now that depends upon whatever will be a unit. It might be kilowatt or it might be a megawatt. So this is the definition of heat rate curve. It is a slope of input output curve at any point. If you see, this is our input output curve. So if we draw a slope here, if we draw a slope to the input output curve, then we will get this curve, that is the heat curve. Now the reciprocal of a heat rate curve is called as a fuel efficiency. The heat rate curve is a plot of heat rate versus output in a megawatt. So this is the third point, that is heat rate curve. Now let me tell you about fourth point is the thing but incremental fuel rate curve. Fuel rate curve, incremental fuel rate curve. Okay, or we are talking about incremental heat curve. So what is this incremental fuel rate curve? Now the incremental fuel rate is equal to small change in the input divided by corresponding change in the output. So how I can define this? Incremental fuel rate. So what it will be? Small change in the input divided by corresponding small change in the output. Now here what is the input? Here if you see, input is nothing but we can say it is the ratio of change in the input required for a small change in the output from a given operating point. So this will be, you can say input is nothing but a fuel, so change in the fuel, and this will be a change in the output, that is PG. So how I can define this, how I can write a definition? So I will write it definition for you. It is defined as, so I will write it is defined as a ratio of change in input. Now why this change in input is required? It is required for a small change in the output from a given operating point. From a given operating point. So let's say, suppose the whatever generation, if we now, as we know that whenever demand is more, then we need to increase the generation. So whenever we require to increase the generation by a small amount, what we have to do, we need to change the requirement of a fuel also. So that's why, what is the definition of an incremental fuel rate? It is the ratio of change in the input required for a small change in the output from a given operating point. So what is the unit for this? If you see, the unit for this is change in the fuel input, which will be in BTU per kWh. So how we can write the graph for this? How we can draw a graph for this? The graph for this is, this will be output in megawatt, output power in megawatt, and this will be incremental fuel rate. So graph will be like this. Okay. So by how much amount your input is going to be increased, that much amount your output will be increased. This is called as incremental fuel rate curve. Now we will see a next point is nothing but, point number E is nothing but incremental fuel cost curve. Now what is this incremental fuel cost curve? Again, if you see, The incremental fuel cost curve, which is also called as IFC, it is defined as ratio of small change in the input to the corresponding small change in the output. So here already we have written it will be what? It will be delta F upon delta Pg. What is that? Delta F upon delta Pg. So this is the graph already we have drawn. Now it is expressed in rupees per megawatt hour. Rupees per megawatt hour. So how I will draw it? It will be drawn like this. Here on x-axis there will be output power in megawatt. On y-axis, if you see cost of the fuel, what is this? Cost of fuel input, and whatever will be unit associated with it is rupees per hour. So this will be a curve. Nature of the curve will be like this. So as we know, this will be PG minimum. Okay, this will be a PG minimum. This will be a PG maximum. So PG minimum and PG maximum. Now if I take a slope of this, let me draw it like this. It will be like this. And if I draw it like this, okay. So what will be this? This will be a change in a cost of a fuel, which is delta F, and this will be what? This will be your delta PG. This is delta PG. Now the incremental cost curve is obtained by considering the change in the cost of a generation to the change in the real power generation at various points on the input output curve. That is, we can say that slope of the input output curve, which is as shown below. Now I'll draw it like this. So here what we are looking for, change in the cost of a generation to the change in the real, or we can say yes, change in the cost of a generation to the change in the what? To the change in the real power generation. So what I will do now, it is very simple. Let me take a different color so that it will be easy for us. If I draw here a tangent, like this, suppose this is the tangent which is drawn to this curve. So whatever will be angle which is made here, it is nothing but what? It will be a beta. Let's say I will take it as this is also a beta. Now if I take this as a triangle, this is the triangle, suppose. So how I can write? Now how IFC will be obtained? So I can write it as IC of I. What is this IC? It is called as slope of fuel cost curve. What is that? It is a slope of fuel cost curve. So now let's see, I'll draw it here again. It is like this. This is your beta. Now what is this? This will be your delta F. So I will write it as here delta F. What is this? This will be your, let's say up to this, suppose I have taken up to this. If I have taken, then again it will be what? It will be a delta PG. So I can write it as tan beta will be equal to what? Delta F upon delta PG. Unit for this is rupees per megawatt hour. Now the incremental fuel cost IC or IFC at I number of thermal unit is defined for a given power output as the limit of ratio of increased cost of the fuel input to the corresponding increased in the power output megawatt. Okay, so let me write it here. What is the meaning of IFC? I will write it for your understanding so that it will be easy. So IFC at I number of thermal unit, ith thermal unit. Now ith thermal unit is defined as for a given power, as the limit of ratio of increased cost of a fuel. which is represented by what here? Represented by delta F. Increased cost of a fuel, which is in rupees per hour, to the corresponding increase in a power, corresponding increased in a power output, which will be taken in terms of what? Which will be taken in terms of megawatt, as the increasing power output approaches zero. Now how I can write? What is the meaning of this? Let me tell you. IC of I, or incremental fuel cost of I, will be equal to limit of, here we have written limit of what? Change in the fuel cost correspond to what? Correspond to increased in the power. So delta PGI, and here we can write it as delta PGI tends to 0. Or in other words, how I can write incremental fuel cost or IC? I can write it as dFi upon dPGI. In some books it has been written like this, dCi upon dPGI. So therefore this particular equation, what is this? Now it is very important because we have to solve few numericals for economic load dispatch, and for that if we have an equation, cost equation C1 or F1 has been given, then how to find it out incremental fuel cost? Just we have to take derivative of this. So this particular dFi upon dPGI, or this, whatever this we have drawn here to the right hand side, right, written here right hand side, it is called as incremental fuel cost of I number of unit, ith unit, incremental fuel cost of ith unit, where this Fi, or sometimes we can write it as Ci, it is nothing but, as I told you earlier, it is cost of a fuel, cost of the fuel of ith unit. Okay, and what is this PGI will be equal to? PGI is nothing but power generated, or you can say output power generated by ith unit. So now please remember, what is the equation of a curve? Now here if you see, here we have drawn a curve. So but obvious, this is what? This is the parabola, and parabola equation will be ax square plus bx plus c. So now please keep in mind, this is very important equation. This is very important equation that you need to remember. The equation of a curve, the equation of a curve will be, what is the equation of a curve? Here Ci will be equal to what? Half into Ai PGI square plus Bi into PGI plus Di. So what is this? Ci will be equal to, this is nothing but your total cost of generation. Then if you see here, this Ai, Bi, Ci, we have these constants. Okay, so what is this? What is the meaning of this? Let me write it here. What is PGI? PGI is nothing but active power. It is what? It is active power generation. Active power generation of ith unit. The power which will be generated by a I number of units, active power. Now there are some variables, Ai is there, Bi is there, Ci is there. These are the constants of input output curve. These are what? Constants of input output curve. Now what this Ai measures? Please remember, this Ai measures losses in the system. It measures losses in a system. This Bi, why it is used? What is the meaning of that? it is a indicative of a fuel cost. It is indicative of a fuel cost, and whatever term this DI is there, it is related to some kind of salary or wages of crew members or some interest or depreciation. So keep in mind, this will be what type of equation it is. This is your second degree polynomial. This is your what? Second degree polynomial. So this is the equation of that whatever curve here we have drawn. This curve we have drawn. This is the equation, mathematical equation of this curve. Now what I can write here? Now for varying PGI, we will get a different cost values, because if we are, as we already have studied that whatever will be a change in the power generation, here there will be a change in the cost of fuel, DCI. So the incremental cost, which is called as incremental fuel cost, or which is also called as incremental cost, which will be equal to what? DCI upon dPGI. So if you take a derivative of this expression, so what you will get? You will get it as AI into PGI, because these two will get cancelled, plus BI, and unit for this is rupees per megawatt hour. We can say we will get this expression as a linear approximation. We will get this expression as in terms of linear approximation. Means what? When we are trying to draw some kind of, or when we are trying to plot a slope of input output curve, where what is this value of I will be equal to 1, 2, 3 up to n. Now the fuel cost is a major component, and whatever remaining things will be there, that is losses, salary and wages, etc., will be a very small in the percentage compared to that of your fuel cost. So therefore the IFC, what is this? IFC or incremental fuel cost is very significant in economic loading of a generating unit. So this is what is the topic in which we have discussed few important definitions: input output curve of a unit, cost curve, heat rate curve, incremental fuel heat rate curve, incremental fuel cost curve, and what is the meaning of incremental fuel cost, IFC, its definition, its mathematical expression. Then what is the cost equation associated with that curve? CI equal to half AI PGI square plus BI PGI plus DI, and how we are going to find it out? IFC from this curve. So this is what is the revision of a cost curve and incremental cost curve of a thermal unit. Thank you for watching this video. If you have any doubt, please feel free to ask any questions. Thank you once again.